Okay, and this next one it says to find the future value at 4.55% interest compounded continuously for 9 years of the continuous interest stream with a rate of flow of f of t equals 4500 e to the negative 0.02 t. Okay, that's a mouthful. But here's our formula, which is another integral formula. By and large, though, all we're going to do is just plug the numbers into the formula. Notice we have something for this f of t. We got something here to plug in for that. We also have something for interest rate, r. There's an r in the formula as well. So we're going to plug in there for the r. We may need to make sure to convert this into a decimal, though, first. So let's move the decimal point over and write it as 0.0455 for r. Now we have two letters for t. There's a lowercase t and an uppercase t. The uppercase t is what we're going to be plugging our number in for here. That's time, so that would be 9 for 9 years. Okay, so these are the three things we need to put into the formula here. If I do that, it's going to look like e raised to the 0.0455 times 9. Then we write the integral symbol, 0 at the bottom, capital T at the top, so that'd be 9. Okay, and then the other parts here will be the 4500 e raised to the negative 0.02 t times e, there's another e in here in the formula that goes negative e raised to the negative 0.455 t, then followed by dt. So we're not plugging anything for that lowercase t here. It's just going to be this stuff here, this stuff here, okay? That's where we're substituting in to the formula. Lowercase t, it just stays lowercase t in this case. Okay, that's our formula here. Now, one thing we'll need to do is we've got these two e's next to each other. These exponents are going to add together. So let's go ahead and do that here. Let's write this as e. We'll go ahead and multiply some numbers together. Be raised to the 0.4095 integral from 0 to 9 of 4500 e raised to the negative 0.0655 t dt. Now we need to take this integral here and do all the work with it. To do this calculation, we'll do the number out in front, e raised to the 0.095, multiply times, let's find the antiderivative, plug in 9, find the antiderivative, plug in 0. Okay, the antiderivative here, we can find it out using this setup here. We still have 4500 e raised to the negative 0.0655 t divided by negative 0.0655. So when you try to take the antiderivative of this e stuff, go ahead and keep that stuff, but divide by the exponent down below. So what we're going to have to calculate here is e raised to the 0.4095 times 4500 e raised to the negative 0.0655 times 9 divided by negative 0.0655 minus 4500 e raised to the negative 0.0655 times 0 all over negative 0.0655. Okay, this is plugging in the numbers here for 9 and 0 into our antiderivative. Here's what it looks like all in the calculator. It comes out to be rounded off to the nearest cent, a total of $46,085.11. Okay, on this next one, it says starting at age 20, you deposit $3,000 a year into an IRA account. Treat the yearly deposits into the account as a continuous income stream. If the money in the account earns 5% compounded continuously, we're going to go ahead and find how much will be there after 45 years. Okay, now this one also uses the formula from the last one where we talk about, quote, continuous income streams. This is the formula here. So let's fill it out here with the interest rate R is 0.05 from the 5%. The time, capital T, is 45 years. The continuous income stream, the amount of money that's being deposited, in the formula, that's what they call F of T. So our F of T in this case is just $3,000 on its own. Okay? So let's put all that into this formula here. It's going to go E raised to the 0.05 times 45, integral from 0 to 45, 3,000 E raised to the negative 0.05 T dt. Again, remembering that these are the only numbers we're plugging in for. And the t, lowercase t, is not plugged in just yet until after we find the antiderivative here. I went ahead and multiplied some numbers here to make that e raised to the 2.25. Integral from 0 to 45, 3,000 e raised to the negative 0.05 t dt. Okay, now we need to find the antiderivative here again. And kind of like the last one, the way we can find the antiderivative is to do 3,000 e raised to the negative 0.05 t. That part doesn't change, but in the antiderivative we'll have to divide by negative 0.05. Okay, so when we calculate here, we're going to be calculating the antiderivative, but we have the e to the 2.25, I should say. Then we got to calculate antiderivative, plug in 45, minus, plug in 0, and see what happens. So what's going to look like here is e raised to the 2.25. Then we'll have 3,000 e raised to the negative 0.05 times 45 divided by negative 0.05 minus 3,000 e raised to the negative 0.05 times 0 divided by negative 0.05. Okay, here shows the calculator after doing this. Ignore the last one in there from the other example. It comes out to be here rounded off to $509,264.15. Okay, now part B asks how much of this is interest and how much of this is money that was deposited. Well, in this case, there's 45 years of $3,000 deposits each year. So the amount of money that was deposited is 45 times 3,000, which is $135,000. If we take the amount of money that'll be there at the end, and we subtract away the $135,000, we'll come out with a total here, and this is just going to be the interest then, $374,264.15. That's just the interest alone.